One thing I wanted to say about this before we get started is that as I went through this review, it turned out to be a pretty long review because I basically went through every problem, and if I didn't work it out, I gave you hints and strategies for each one. Feel free to skip along, go to the problems that you're having trouble with, really listen to the instruction there, and then ignore the ones that you already know. That'll make the review go a lot quicker. But most of all, do the work yourself, okay? If you're not doing it yourself, there's really no reason why you should be listening to this review in the first place. All right. Do the work. Good luck on the test. Hey, welcome to the Unit 6 review for the Unit 6 test. We're going to go through some of these problems and I'll solve them with you here. The first one is 3 times the square root of 60. Now, one thing that you have to remember for this problem is don't forget your 3. One of the biggest mistakes is you get done factoring out 60 and simplifying that radical, and then you forget to multiply by 3. So definitely don't forget to do that there. All right. We're looking at 3 times the square root of 60 in this, right? And so we're going to factor out this, and if you don't recognize any perfect squares in your radical, then go ahead and just divide by the smallest number you can. In this case, it's that's the radical 2. And I'm going to keep all my what I call dead ends in that little kind of teal color right there. And you'll see why in a little bit. And so the square root of 2 times the square root of 30 is 60. And so I'm going to factor that out. And once again, I divide by 2, or the square root of 2. So radical 2 is another one of my dead ends. And the other factor of 30 is the square root of 15. And I can even factor the square root of 15 down. And it factors into 2 dead ends, the square root of 3 and the square root of 5. Meaning the square root of 5 times the square root of 3 is 15. Okay, so right now I've got all my dead ends. I've got the square root of 2, the square root of 2, the square root of 3, and the square root of 5. And so I'm going to try to figure out what I can do with all of these dead ends here. All right? Are there any that I can take out of the radical? So I'm going to bring my square root of 2 over here. I'm going to bring this square root of 2 over here. And I'm going to bring this square root of 2 over here. And finally, I'll bring this square root of 2 over here. Because really what it is just square root of 2 times square root of 2 times square root of 3 times square root of 5. Okay? And we can even erase this other stuff because we don't really need it. All right. So I end up with the square root of 60 equals the square root of 2 times square root of 2 times square root of 3 times square root of 5 here. So I know that the square root of 2 times the square root of 2 is the square root of 4. And what is the square root of 4? 2, right? So I can take the square root of 2 times the square root of 2, and it becomes 2. right? Because the square root of 2 times the square root of 2 is the square root of 4, which is 2. And really, any number multiplied, if it's root, whatever that number is, times itself, is just going to give you that number. So, if I had the square root of 13 times the square root of 13, guess what it would be? 13. Notice there's no square root over that 13. It's just 13. So I end up with 2 times the square root of 3 times the square root of 15. Now there's nothing I can really do with the 3 and the 5, right? So I'm just going to multiply those back like we had them last time, and that's going to turn into the square root of 15, and I've got 2 times the square root of 15. Okay, so I'm done, right? It's 2 root 15. Well, not entirely, because remember this guy right here? It was 3 times the square root of 60. So here's the square root of 60 right here, and then I'm going to take this 3 here, and I'm going to multiply it. 3 times 2 times 15. Well, what's 3 times 2? 6. And then times square root of 15. Okay. So, if you're still unclear on that, you can rewind this. If you got it, anytime you understand a concept, you don't have to keep watching it. You can, of course, fast forward through it all. Alright. So, let's take a look at the square root of 88. Go ahead and try it now, and I'll wait for you to pause the video, and once you've done it and come up with an answer, then come back and we'll rework it. Okay, so we started off with the square root of 88, and we're going to factor that down, boom, boom, and we're going to try to come up with all our dead ends. I've got the square root of 2, or radical 2, times radical 44. I know I can factor that more. Anytime it's even, and it's not 2, you can factor it out a little bit more. 2 times 22 is 44. Root 2 times root 11 is 22. And can I do anything else with the square root of 11? No, there are no factors. It's a prime number. So no factors other than 1 and 11. So that's a dead end as well. So here are my dead ends. So I'm going to take those dead ends and I'm going to move them down here because I want to multiply them all together here. Alright. I'm going to make some room. And remember that all we're saying is the square root of 2 times the square root of 2 times the square root of 2 times the square root of 11 equals the square root of 88. That's what all these factors mean, right? Okay, so we know that the square root of 2 times the square root of 2 is just 2 times, and we've got the square root of 2 times the square root of 11. Well, if it was the square root of 2 times the square root of 2, then I could pull out a 2. But there's not a lot I can do with the square root of 2 times the square root of 11. So I'm just going to say times square root of 2 times 11 is 22. And that's about as far as I can go with this. So 2 root 22. is going to be my final answer for that. All right. Moving right along. Okay, this is another one that we had trouble on the quiz. So, what's wrong with this fraction? If you answered it's got a radical in the denominator, then you are correct. So what do we have to do? We have to multiply this radical times itself, square root of 6. But we can't do anything that affects the actual outcome, the value of that fraction. So we're going to be multiplying it times 1. Well, square root of 6 over the square root of 6 is really just 1. Remember, 1 is anything divided by itself, right? That's just 1. So we're not going to be changing the value of the fraction. Well, the square root of 6 times the square root of 6, remember you get rid of the radical, so it's just 6. Okay? And then 5 times root 6 is just, well, it's 5 root 6. Now, is there anything I can do? Can I divide 5 by 6 evenly? Anything like that? Nope, not really. So I can just say 5 times the square root of 6 over 6, or I could say 5/6 times the square root of 6. Both of those would give you the same outcome. All right? Okay, you know how to do this one on the calculator, but make sure that you know how to write this out here. So we've got 2 times the square root of 7, and remember this is squared, right? Times 2 times the square root of 7. Well, what's the square root of anything times the square root of itself? It's just that number, right? So the square root of 7 times the square root of 7 is 7. And then 2 times 2, well, we know that one. That's 4. So now I have 4 times 7 equals 28. There you go. Number 5 we're not going to really work through, but I am going to draw your attention to something. It says round to the nearest hundredth, right? So if you get an answer like c squared equals 1,345, then you know you're going to have to square root both sides, right? And you'll get c equals, and then you just plug 1,345 into your calculator. When I enter that into my calculator, it says 36.67, and it goes on, but since this is my 100th spot, and it asks me to round to the nearest 100th, that's where I'm going to stop. So my final answer is 36.67. And the nice thing about this is that I don't have to factor 1,345. I can just put it in my calculator. But make sure that you pay attention to what it asks you for here. Okay. I'm not saying this is the right answer, by the way. I'm just giving this as an example. All right. Number 6, find the missing side. Give the exact form, the exact radical form. So your answer is going to be probably going to have some kind of radical in it, and approximate form, round to the nearest 100th. That's just like we did last time. Still, you're going to have your c squared equals your a plus your b right here. So you'll still have 81 equals a squared which is 25 plus b squared, right? You'll subtract 25 from both sides because you want to get away from, you want to get b alone, I mean. And so, let's see, 81 minus 56 equals b squared. And of course you're going to take the square root of both sides of those. And you get b equals the square root of 56. Now for your approximate, you just enter it into the calculator. But for your exact, you're going to have to factor. Okay. I'm going to leave you to figure out what that is. Okay, number 7. A fence around a square garden has a perimeter of 48 feet. Find the approximate length of the diagonal of this square garden round to the nearest hundredth. Well, remember, it's a square garden, so that means that each side is going to be the same. Let's just call each side S. S, S, S. And so your perimeter is going to be 4S because it's just adding up each side. 1, 2, 3, 4. Okay. Now, this tells you your perimeter. It says it's 48 feet. So instead of having our perimeter here, we can just move this aside and we can put in 48 feet. Divide both sides by 4, and you get S equals 12. So remember, S is each side, and so equals 12, 12, so on and so forth, right? Okay. Now what is it asking? The length of the diagonal. Now remember, diagonal is the line that goes from one corner of the square to the opposite corner of the square. So it looks like you have this side and this side are the same. What does that mean about the angles? The angles of each of these, or the angles, measurements of each of these corners here are 45 degrees. And this, of course, is 90 because it's a square, and all your angles in your squares are going to be 90 degrees. Okay. So this is 12 and this is 12, and you can do it either of two ways. You could say, you know what, I remember that for my 45, 45, 90 degree triangle, my hypotenuse is always just x times root 2, where x is either side of my triangle. So if my side of my triangle is 12, then I know that my hypotenuse is going to be 12 radical 2. Okay? Or you could draw out the triangle that you know, the 1, 1, root 2 triangle, and draw out the triangle that you're trying to solve for, 12, 12, and then x on here, and then just set up that ratio. X over the corresponding side in your known triangle, and 12 over that other corresponding side, the side that corresponds to 12. 1. Cross multiply, and you get x equals 12 root 2. So either way would be fine. Alright, so there's that lovely paper all filled up here. Let's go to the next. Find the measure of the diagonal of a rectangle whose sides measure 15 and 18, round to the nearest hundredth. So first of all, always I'm going to draw out my shape. It's my rectangle. Sides measure 15, and I guess that should really be my 18 side. It's 18 and 15. I need to get my measure by diagonal. There's my diagonal right here. So I'm really looking at a triangle, right? Where my A is 18, my B is 15, and I don't know what my C is. And so remember, C squared equals A squared plus B squared, which means C squared equals 18 squared plus 15 squared. Then I get C squared equals 324, which is 18 squared, plus 225, which is 15 squared. And if I add those together, C squared equals 549. But, of course, I'm not done yet because I have to take the square root of both sides. And do I have to factor, or do I plug it into my calculator? Well, let's go back and see what they're asking for. It says round to the nearest hundredth. So all I have to do is plug that into my calculator. And I get C equals 23.43. And that's as far as I go because this is my hundredth. All right. I will let you answer B for yourself. All right. Mr. Carpenter built a wooden gate as shown below. Well, first, let's get rid of the rest of this stuff here. What is the closest to the length in feet of the diagonal board that Mr. Carpenter used to brace the wooden gate? So it looks like this is the diagonal board right here. And we're looking for the closest to the length in feet. Now, I'm not going to do this for you, but I will give you a hint. You know that this distance right here is 3.5 feet, right? This distance we do not know, so we'll put x there. And this distance, be careful, because you have 1 foot extra here, 1 foot from here to here, which is the same as here to here, right? And then you have a foot extra here, from here to here, or the same as here to here. The entire length is 6, so watch out what you put for this side right here. Number 10, Miss Van Pelt hired a landscaping service to plant a row of bushes around her triangular backyard. If the bushes must be planted 3 feet apart, approximately how many bushes are needed for Mrs. Van Pelt's backyard? Well, I won't do this one for you, but I'll tell you the strategy for it. Sounds like you're going to want to figure out what the perimeter is. What the perimeter is, and then you're probably going to want to divide that perimeter by 3. Why? Because the bushes are going to be planted 3 feet apart. So for every 3 feet you have, you're going to have 1 bush. All right. Okay, let's go on to the next one. This is asking you to find the exact answer for this. And notice that this is a 30, 90, and so what does that make this other angle? 60. Triangle, our 30, 60, 90 triangle. And if you remember, the numbers for our 30, 60, 90 triangle is, if this is 1 right here, then you know that this is that our longer leg is root 3, and that our hypotenuse is 2. So you've got this triangle, the one that we're trying to figure out, and you have your known one. So let's draw your known. 1, root 3, 2, right? And so first they want you to try to find x right here. Here's your x. So just draw out that known triangle and always start with your x. And let's say x over, now your x is along your hypotenuse, right? So what side of your known triangle corresponds with x? Well, of course, it's the hypotenuse of the known triangle. So you put that measure down here. And then you go for the side of the triangle that you're working on that you know, which is 15. Put it in the numerator. And what side of your known triangle corresponds with 15? 1. 1. You want to cross multiply. And so we get x equals 2 times 15 is 30. Alright, so that's our 30. Now we have to find our y. And so we can do the same thing. Here I'm going to erase all this mess right here. So we can start with a fresh slate. Okay, here's my known. 1, root 3, 2. By the way, remember that the way I remember the what the sides are for my 30, 60, 90 triangle is, since there are 3 different sides, 1, 1, 2, and root 3, then there is a 3 under the radical sign. But for my 45, 45, 90 triangle, there are only 2 values, 1 and root 2, so there's a 2 under the radical sign. Okay, so once again I'm going to set up my ratio. This time I'm looking for y, so I'll start with y. Y over, well, it's this side on the triangle that I'm trying to figure out, so what side is it on my known triangle? It's this side on my known triangle. So I'm going to put that on the bottom. And then I go back to the triangle I'm trying to figure out, and I take the side that I know, that's 15, over, and the side of my known triangle that corresponds with the side I know is this one right here, 1. And of course I'm going to cross multiply, and I just get y equals 15 root 3. All right. Number 12, I want you guys to do the same thing with this one. And so you're going to be setting up the ratio, you're going to be finding it. It needs you to find this side here. Oh, but you know what? Look at this. Oh, never mind. I thought it was asking for something else. All right, carrying on. Number 13 asks to classify the following sides as acute, obtuse, or right triangle, and to show your work. That's a big thing. I can't give you partial credit if you don't show me any work. All right. Well, first of all, what is our test to see if it's a triangle in the first place? Well, we'll have an A, we'll have a B, and our largest side is always going to be C, right? And C has to be, is it greater or smaller than A plus B in order for it to be a triangle? C must be smaller than A plus B. Remember, A plus B have to be able to gang up and beat up on poor old C over here. If they can't do that, if C is bigger, then it's not a triangle. All right. Well, it looks like A is definitely a triangle because 2 plus 10 is greater than 11. So I think we're good to go. We can continue. So now we're going to give it the old Pythagorean theorem, c squared equals, except for this time it's not going to be equals, c squared box a squared plus b squared. In this case our c squared is 11 box a squared is 2 squared plus b squared is 10 squared. And so we get 121 box 4 plus 100 because it's just 10 squared. Alright, so is 121 greater or less than 104? Well, of course the answer to that is 121 is greater than 404. Now remember, if your c squared is greater than your a squared plus b squared, then it's going to be obtuse. The triangle might look something like this, where this is my C, that's my A, that's my B. Notice how my C is big. Alright, we'll do one more. Get rid of all this stuff. Let's look at 10, 11, 14. And so first, we got my A, my B, and my C. And so I'm going to put my C over here, 14. And then 10 plus 11, just to see if it can be a triangle. So can my 10 and 11 gang up and beat up on my 14? 14 is indeed less than 21. So we're good to go. It is a triangle. So 14 squared box 10 squared plus 11 squared. So we get 196 box 100 plus 121. And 100 plus 121 is 221. So it turns out that my c squared is less than a squared plus b squared. That triangle might look something like that, where this is my C. And so that would be acute. That's a U. Acute. Okay. So just remember, if your c squared is bigger, it's obtuse. But if your c squared is smaller, it's acute. What happens if your c squared is equal? Well, that's right. All right. Number 14. A conveyor belt carries bales of hay from the ground to the loft of a barn 27 feet above the ground as shown. 27 feet. If the belt makes a 30-degree angle, here's our 30-degree angle, with the ground, how far does the bale of hay travel on the conveyor belt? So this is what we're looking for. How far does that bale of hay travel? Alright, so let's pop that open and see what we got. Here, we'll put it way up here. So, here's my triangle, 27 by something else, right? Well, we know that it is a 30, 60, 90 triangle. And so we just have to set up a ratio with a triangle that we know. So I'm going to draw my known triangle. And my known triangle has measurements of 1, root 3, and 2. I always start with my x. So I'm going to say x over, and the corresponding part of that triangle is this guy right here. This part corresponds with that part. So 2 over 2 equals, and then I go with the part that I know, 27 over what side of my known triangle corresponds with 27? Of course, that's 1. 1. Cross multiply, and I get 27 times 2, x equals 54. All right. How far does the bale of hay travel on the conveyor belt? 54. And important, make sure you put in those units of measurement. 54 feet. All right. Now, number 15, this is a tricky one. This gets a lot of folks, so pay special attention. The drawing shows how 3 squares can be joined at their vertices to form a right triangle. The areas of the 2 squares are given. So here's this area and that area, and do remember that they are squares, right? Find the side lengths of the right triangle. Okay, so here's our triangle right here, and it's a right triangle. Boom, boom, boom. So our c squared equals a squared plus b squared is going to apply. Now, what's the c of this right triangle? It is always the hypotenuse, right? And then so this could be A, this could be B, that would be fine. All right. If we have the area of this square, then we also know what the side is, and that would give us the C of our triangle. So we basically have to take the area and square root it. Why? Because the area is just going to be area of that square is going to be the side times itself, all right, or just the side squared. Okay. What's the square root of 100? 10, right? So we know that C is 10. Okay, what about over here? What is the square root of 64? 8. So we know that this side is going to be 8. So now we have a triangle with 10, we have a triangle with 8. Now, I could do my Pythagorean theorem and get that, Or 10 and 8. There's something about those that's a little suspicious. What if I divided 10 by 2? What would I get? 5? What if I divided 8 by 2? What do I get? 4. This is a 3, 4, 5 triangle. Remember our Pythagorean triples. 3, 4, 5, 5, 12, 13. Get rid of that. 7, 24, 25, 8, 15, 17, so on and so forth, right? So I have my 4, I've got my 5, just have to put in my 3. Now 3 equals what divided by 2? 6, of course. So I know that this side is going to be 6, because it's a 6, 8, 10 triangle, which is also a 3, 4, 5 triangle. Okay. I know I kind of went through that kind of fast, but if you're still confused, watch it again. See if you can catch what I'm doing. So my sides were, my A, let's just say, was 6. My B was 8. And my C was 10. Okay. With these next few, I won't do those for you because we've kind of gone over the main concepts, but I'll just kind of give you strategies for this. Sam's square bedroom has a diagonal of 9 and radical 2 feet. What is the length of each side? What is the perimeter of his bedroom? And what is the area of the floor? Alright, remember that the perimeter is just, if we're talking about a square, it's just 4 times a side. And then area is just the side squared, side times side. Okay? And then remember, always make a drawing, and that diagonal right here is what they're talking about with the 9 root 2 feet. Okay. Fid the length of TG. Okay. And TG is this one right there. Round to the nearest hundredth. So we're not going to have any sort of radical signs in our thing when it says round to the nearest hundredth. We're probably going to have decimal point for 3 or something like that. But just decimal point with 2 numbers. So the strategy here, of course, is you need to find from this triangle here, you can find this side, and then after you found that side, then you can find your C, your TG. Find the length of the hypotenuse of an isosceles right triangle. Okay, so we're talking about an isosceles right triangle. There's another word for that isosceles right triangle, right? It's a 45, 45, that has a leg 5 inches long. Find the exact and approximate length. Remember, exact will have this, approximate will have some number. And last but not least, find the measurement of the missing sides. Leave the answer in simplified radical form. So we're going to have some kind of radical there. And remember, for your 45, 45, you're just going to draw a known triangle, and that known triangle has these measurements. You'll try to figure out what you're doing. You'll start with your x, and then you'll just set up a ratio from there. I'm going to let you do that, and I'm going to let you do the rest. Well, there's not even any. I'll let you alone, And if you have any questions about this, you can of course always go back and then take a look at just a little part, one section of this review, or just ask me. All right. Good luck on the test.